A withdrawal reflex involves muscles contracting to withdraw the body part away from a painful stimulus. This reflex involves pain receptors termed nociceptors. It is initiated by a painful stimulus, such as touching something very hot or painful. This stimulation initiates a nerve signal that is transmitted by our sensory neuron to the spinal cord. Interneurons receive the sensory nerve signal and stimulate motor neurons to the flexor muscles. These flexor muscles contract in response. For example, when you step on a sharp object, sensory neurons detect the sensation and transmit nerve signals to the spinal cord. They synapse with interneurons, which stimulate motor neurons to contract the flexor muscles. You lift your lower limb up and away from the painful stimulus. In addition, reciprocal inhibition occurs with the extensor muscles, so the hamstrings cannot contract unimpeded.
Reflexes are rapid, pre-programmed, involuntary responses of muscles or glands to a stimulus. An example of a reflex occurs when you accidentally touch a hot burner or stove. Instantly and automatically, you remove your hand from the stimulus, even before you are completely aware that your hand was touching something extremely hot. All reflexes have similar properties. A stimulus is required to initiate a reflex. A rapid response requires that few neurons are involved and synaptic delay is minimal. A pre-programmed response occurs the same way every time. An involuntary response requires no conscious intent or pre-awareness of the reflex activity. Thus, reflexes are unusually not some person.
Generally, 5 steps are involved in a reflex. A stimulus activates a sensory receptor. A sensory receptor responds to external and internal stimuli such as temperature, pressure, or tactile changes. The sensory neuron transmits a nerve signal to the CNS. A sensory neuron transmits a nerve signal from the receptor to the spinal cord or brain. Information from the nerve signal is processed in the integration center by interneurons. More complex reflexes may use a number of interneurons within the CNS to integrate and process incoming sensory nerve signals and transmit information to the motor neuron. The motor neuron transmits a nerve signal from the CNS to an effector. The nerve signal is transmitted through the anterior root of a motor neuron and then the spinal nerve to the peripheral effector organ. The effector responds to the nerve signal from the motor neuron. An effector is a muscle or a gland that responds to the nerve signal from the motor neuron. This response is intended to counteract or remove the original stimulus.
Biceps reflex. Flexes elbow when biceps brachii tendon is tapped. Triceps reflex. Extends elbow when triceps brachii tendon is tapped.
Patellar reflex. Extends knee when patellar ligament is tapped. Ankle reflex. Plantar flexes ankle when calcanean tendon is tapped.
Abdominal reflexes. Contract abdominal muscles when one side of the abdominal wall is briskly stroked.
Plantar reflex. Flexes toes when plantar side of foot is briskly stroked.
Stretch reflex. The stretch reflex is a muscle reflexively contracting in response to stretching of a muscle. Stretching a muscle is monitored by a muscle spindle. A muscle spindle may be stretched if either the entire muscle is stretched or lengthened, or if a portion of the muscle that contains the muscle spindle is lengthened. When the muscle spindle is stretched, the sensation is detected by sensory neurons that are wrapped around the intrafusal muscle fibers of the muscle spindle. The sensory neurons transmit nerve signals to the spinal cord, where they synapse with the alpha motor neurons associated with that muscle. The alpha motor neurons then transmit nerve signals to the extrafusal muscle fibers, which causes the muscle to contract and thus resist the stretch.
Hypoactive reflex refers to a reflex response that is diminished or absent. This may indicate damage to a segment of the spinal cord or may suggest muscle disease or damage to the neuromuscular junction. Hyperactive reflex is an abnormal strong response. It may indicate damage somewhere in either the brain or spinal cord, especially if accompanied by clonus. Clonus is arrhythmic oscillations between flexion and extension when the muscle reflex is tested.